we're asking specifically about hybridization, and we have different cases here. Let's start with BRF3. Our process is always make the best Lewis structure, then figure out how many electron groups are on the central atom. Let's see, 7 plus 7 times 3 equals 28 electrons. Our Lewis structure will be bromine, fluorine, fluorine, fluorine. Bromine is less electronegative. It's also listed first. We know that's generally how we find the central atom. And then we have 2, 4, 6. We now put 8, 10, 12, 14, 16, 18, 20, 22, 24. We still have 4 more electrons to do. Since I have 4, I'm going to sort of angle them around the fluorine like this. Sorry, around the bromine. Finally, we have 5 electron groups. For 5 electron groups, the electron geometry is trigonal bipyramidal. And for 5 electron groups, there are 5 hybridized orbitals. 1, 2, 3, 4, 5. It is sp3d hybridization. And our bond angle, or in this case bond angles, since there is at least 1 pair of electrons, would be less than 90 and less than 120 degrees. And for a picture of this, and I'll take some space here for this. So we have our bromine. We have 1 up, 1 down, 1 to the left, or right really, but, and then on the other side, there's an out wedge, which I really should do a better job of coloring in, and a back wedge. These are the 5 positions, and it turns out that whenever you put a pair of electrons, so electron pairs, go into what are called the equatorial positions. And the equatorial positions, so this is like a trigonal planar molecule, so each of these bond angles is 120 degrees. And for the straight up and straight down, the bond angles are 90 degrees. That's why there's 2 different bond angles. Now the electron pairs go into, and so these 1, 2, 3, these are the equatorial positions, all 3 of them. So we'll put, it doesn't matter which ones. Let's put a pair of electrons there and a pair of electrons there. We'll put our fluorine, and our fluorine. And this top and bottom positions are called axial. And that is a proper shape. So that's where the 90, and then of course, because we have pairs of electrons here, we would then finally note they're less than 120 and less than 90. Those are the actual bond angles. Any questions about number 1 here? Or let's say question 2 of 4, we'll call it.
Yes, Professor. Please, what do you mean by 5 electron groups?
Great question. So if I come back to my Lewis structure, I have 1, 2, 3, 4, 5. So each an electron group, so 1 electron group can be 1 pair of electrons. It can be one single bond, it can be one double bond, or it can be one triple bond. Oop, there we go. So basically it's any place there are electrons, and each of these pairs of electrons is a different electron group. So one pair is 1, 2, 3, 4, and 5 electron groups. Does that answer your question?
Yes, but Professor, this bromine, it's exceeded the octet rule. Is it among the expanded octet group?
It is definitely part of the expanded octet. Oh, I don't even know why I can't find my periodic table. I hung it on my lamp that's over there. So here it is. Sorry about that. All right, so expanded octets are all of these. Aluminum to bromine and down, or sorry, aluminum to argon and down. So bromine, iodine, selenium. What you'll notice is that as you go down, you actually cross this line into the metals, and the metals don't typically do it. These are typically, since we're talking about covalent bonds, it will typically be phosphorus, sulfur, chlorine, selenium, bromine, and iodine that form the expanded octets.
Thank you.
Sure. Sorry. I should open my eyes a little bit, eh? All right, I'll put it back on my lamp. And now I can still see it. Any other questions about BRF3? If not, then we'll finish this part up with ammonia. Ammonia is going to have 5 plus 1 times 3, which is 8 electrons. Nitrogen has to be the central atom. And then we put electrons 7 and 8 on nitrogen because there's no other place to put them. We see that the central atom nitrogen has 4 electron groups. 4 electron groups means sp3 hybridization. It means tetrahedral electron geometry. And the bond angle will be less than 109.5. Any questions about ammonia? Okay, so if not, then let's take a 10-minute break. We have a couple more questions to do. We'll come back and do those.